This geometry puzzle is incredibly satisfying because the final answer hides behind just one clever construction. We have a large triangle, ABC. There's a point P sitting somewhere along the bottom side, BC. Now here's what we know. The angle at B is 44 degrees, and the smaller angle near the top, angle BAP, is 24 degrees. But the most important clue is about the lengths. The entire left side, AB, is exactly equal to the segment CP on the base. Let's call both of those lengths A. And for convenience, let's call the smaller segment BP B. Our mission is to find the angle at C. We'll call it X. Now here comes the clever move that unlocks the whole problem. We place a brand new point on the base between P and C. Let's call it point Q. And we choose Q very carefully so that BQ is also equal to A. Then we draw the segment AQ. That single line creates all the hidden symmetry in the puzzle. Now let's analyze the base carefully. The whole segment, BQ, equals A. But the first part, BP, equals B. So the middle piece, PQ, must be A minus B. Now look at the right side. The entire segment, CP, is also A. If we subtract PQ, which is A minus B, A minus A minus B, the A's cancel out completely, and we're left with B. So CQ equals B, which means something beautiful just happened. The small segment on the far left, BP, and the small segment on the far right, CQ, are exactly the same length. Now focus on the large triangle, ABQ. Two of its sides are equal. AB equals A, and BQ also equals A. So triangle ABQ is isosceles. The angle at B is 44 degrees. That leaves 180 minus 44, which is 136 degrees. And since the remaining two angles are equal, each one must be 68 degrees. So angle AQB is exactly 68 degrees. Keep that number in mind. Now let's look at the smaller triangle, ABP. Angle B is 44 degrees. Angle BAP is 24 degrees. Using the exterior angle theorem, the exterior angle at P, angle APQ, must equal 44 plus 24, which gives us 68 degrees again. And now the hidden pattern appears. Inside triangle APQ, both bottom angles are 68 degrees. That means triangle APQ is also isosceles. So its two equal sides are AP and AQ. We're almost done. Now compare the two outer triangles, triangle ABP and triangle ACQ. First, BP equals CQ. Both are B. Second, AP equals AQ. And third, look at the included angles between those sides. Each one sits beside a 68-degree angle on a straight line. So both included angles equal 180 minus 68, which is 112 degrees. Side, angle, side. The two triangles are congruent, which means their matching corner angles must also be equal. The left corner angle at B is 44 degrees, so the right corner angle at C must also be 44 degrees. So X is 44 degrees. Such a beautiful puzzle. Nothing here was random. Everything snapped together perfectly once that extra point Q was added. Did you see the symmetry coming before the congruent triangles appeared? Let me know, and I'll see you in the next one.